Hi, welcome to this video. We're going to discuss today the quick multiple choice questions regarding the chapter 21, the theory of consumer choice. Remember, this is a book of Gregory Mankiw, Principles of Economics. So the first question says, Emilio buys pizza for $10 and soda for 2. He has income of $100. His budget constraint will experience a parallel outward shift in which of the following events occur. So first, I want to introduce better the idea. Then we know that the price of pizza is exactly equal to $10. Then the price of soda is exactly equal to 2. And then the income is 100. Then, if we want to represent graphically the budget constraint of Emilio, we need to label first the x's. So we're going to label them as the quantity of soda or the quantity of pizza. If you are asking, or maybe you wonder why I put in that order, it doesn't matter. You can just change them, it's the same. So then, the point here is that this point in the y-axis, when exactly the budget constraint crosses the y-axis, it is the point when you spend all income in the good that is located in y-axis. In this case, soda. Then, if we have available 100 and the price of soda is 2, it means that if you spend all your money in this good in soda, you will get at the end of the day 50 units of soda. So could be 50 cans if you want. Then the other one should be 100 because of the income over the price of pizza. This should be 10. So then it should be 100 over 10. As an answer, we will have 10. Then this should be that all income is spent in pizza. So this is how we can represent the budget constraint. Then we know that what we want to represent is a parallel outward shift. It could be the case that you have more income, so automatically you can consume more of both goods. And remember that the slope of the budget constraint is given for the relation of the prices. So then, at the end of the day, if the relation of the prices it doesn't change, it means automatically that the slope of that curve will be exactly the same. The second situation could be that there is a decrease in the same proportion of prices. If that is the case, you can think between quotation marks that you are richer. So then you are more quantities available due to the same or taking into account the same income. So then this should be the case. The slope remain the same and the curve shift outward parallelly. Then the answers are A. The price of pizza falls to $5, the price of soda falls to $1, and his income falls to 50. Second situation, the price of pizza rises to 20, the price of soda rises to 4, and his income remains the same. The price of pizza falls to 8, the price of soda falls to 1, and his income rises to 120. The last option, the price of pizza rises to 20, the price of soda rises to 4, and his income rises to 400. Then we're going to go through all the answers. So the first one, we know that the price of pizza falls to 5, the price of soda falls to 1, and his income falls to 50. Then, first, this is the initial situation. Then we know that's the case. Then we know that the slope of this curve is given by the negative of the price of pizza over the price of soda. So then we have that the slope should be minus 5. Then we know here, actually I'm thinking that this should be maybe the price of soda over the price of pizza, but it doesn't matter for the case of our exercise. We know just like the slope should be minus 5. Then the price of pizza is equal to 5, the price of soda is equal to 1, the income is equal to 50. So then in that case should be the slope minus 5. We know that slope should be minus 5 because if the price of pizza is 5 over 1, then it remains the same. So we can say, okay, this slope has not changed. So then could be a parallel movement. Then regarding the situation, so we have the income, which is 50 over 5, which is the price of pizza. Then you spend all the money in pizza, you will get 10. So this is exactly the same. Then to the other one, 50 the income over the price, you will get 50. So then at the end of the day, you will have here that you have exactly the same curve. So at the end of the day, the budget remained the same. It's exactly the same. So then this cannot be the complete answer. Second one, the price of pizza rises to 20, the price of soda rises to 4, and his income remains the same. So then the price of pizza is equal to 20, the price of soda is equal to 4, and then income is exactly the same. The slope should be price of pizza 20 over price of soda 4. Then you will get a slope minus 5. Then it's exactly the same. So we're getting right here. Then we know here that this is the first situation. Then the other one should be 100, which is the income over the price of pizza, which is 20. The answer should be 5. And the other one is 100, which is the income over the price of soda, which is 4. Then you will get 20. Then at the end of the day, this one effectively is a movement, but it's a parallel inward shift. What we're looking for here is a parallel outward shift. So then this cannot be the answer. The other one, the price of pizza falls to 8, the price of soda falls to 1, and his income rises to 120. Then the price of pizza is equal to 8, the price of soda is equal to 1, actually here should be 1, and the other one, the income should be 120. So then here we have minus 4. Actually, I would say that is wrong, because if the price goes that way to 1, they should be over 1, right? And then this one should be minus 8, right? Then this is different, so we cannot go on because the slope is different, so then it doesn't work. Then it's not a parallel movement. Then going to the last one, this should be the good one. The price of the pizza rises to 20, the price of soda rises to 4, and his income rises to 400. Then the price of pizza is equal to 20, the price of soda is equal to 4, the income is 400, then the slope should be 20, which is the price of pizza over 4. The slope is exactly the same, so we are okay here. Then the initial situation, we have this one, and then 400, which is the income, over 20, which is the price of pizza, then should be equal to 20. And the other one is 400 over 4, which is the quantity of soda, then should be 100. Then at the end of the day, this one should be the new budget constraint. So we represent here a parallel outward shift. So this should be the wood one. We see here the situation where the the prices changes proportionally because they were um, double all two, and at the same time we see an increase of the income, right? So besides the increase of the price, it was compensated with 4 times the income, which makes that the parallel outward shift. Then this should be the answer. Then at any point of on an indifference curve, the slope of the curve measures the consumer's A. income, B. willingness to trade on one good for the other, C. perception of the two goods are substitute or complements, D. elasticity of demand. Then we have here a representation of the explanation of the chapter. We have here quantity of Pepsi and here we have quantity of pizza. Then we have the situation, we have here 3 bundles, and at the end of the day we know that those are the same, like they lie on the same indifference curves, they are preferable as the other ones. So then at the end of the day, we know that those represent preferences. And here, when we have more quantity of Pepsi, then you are willing to change more Pepsi just for a little bit of pizza because this is more desirable. The other side is when you have a lot of pizza and maybe you get thirsty. So in that case, you can change a lot of or too much pizza or a lot of pizza for just a little bit of Pepsi. So then this is the situation that at the end of the day measures the willingness to trade one wood for the other. Third, we have Matthew and Susan are both optimizing consumers in the markets for shirts and hats, where they pay 100 for a shirt and 550 for a hat. Matthew buys 4 shirts and 16 hats, while Susan buys 6 shirts and 12 hats. From this information, we can infer that Matthew's marginal rate of substitution is hats per shirt, while Susan's is. So those are the possible answers A, B, C, D. Then in order to represent better, we have here the price of shirts that they are 100 and price of hats that they are 50. We know that the Matthew he will consume 4 of shirts and 16 of hats. Susan will consume 6 of shirts, 12 of hats. Then we can represent the marginal rate of substitution, how you can change one object to another one. Remember that here is hats per shirt, so they should be hats in the numerator and the shirt in the denominator. So then we have for Matthew 16, 4 over 4, then you will have 4. And it makes sense because you have more hats, so you are able to trade more hats for getting one shirt. So 4 hats in order to get 1 shirt. In the other case, Susan's case, we have 12, the quantity of hats, over 6. So then here we have less quantity of hats and more quantity of shirts. So naturally, the relationship between them should be shorter. So they should be 12 over 6. So Susan is able to change 2 hats for one shirt. So then at the end of the day, we have 4 and 2. Then this should be the answer. The other one, Charlie buys only milk and cereal. Milk is a normal good, while cereal is an inferior good. When the price of milk rises, Charlie buys. So important to think about here. We have two goods, we have the quantity of milk and quantity of cereal. We know that the quantity of milk, this is a normal good. It means that when the prices go up, the consumption go down. When we have the inferior good, it means that when you have higher income, automatically you will start to consume less. Then here, when we have an increase in the price of milk, automatically the budget constraint change of slope, it gets flatter, and then this should be the new budget constraint. Those are the indifference curves. Remember that the maximization situation will be where exactly are the same the slopes of the budget constraint, that is the relationship of prices, and the slope of the indifference curve, that is the marginal rate of substitution. So then here is a situation that we have, those are the answers. Less of both goods, more milk and less cereal, less milk and more cereal, less milk but the impact on cereal is ambiguous. Then here is the initial situation, this is the second. So we have here one representation. When there is an increase of milk in the price of the milk, automatically there is a decrease in the consumption of the milk and in the quantity of cereal. That's the case. But imagine other situation that we have here the maximization and then change the price. This budget constraints moves exactly the same as the previous one, but due to the shape of the indifference curves, we have here that there is an increase in the consumption of cereal. So depending in which movement should be higher, if the income effect or the substitution effect, at the end of the day we can learn which should be the change in the other good. In this one is ambiguous because if that is the case, the cereal will decrease or the cereal consumption will increase if that is the case of the indifference curves. Then Charlie buys only milk and cereal. Milk is okay. So then, because milk is a normal good, consumption decreases. But the cereal has the situation as I said before. Then it's kind of cheaper compared to milk. Then you can compensate more milk giving up units of cereal. So it depends what should be the movement, the shape of the indifference curves. Then we can infer what is the situation of the other good. So then should be less milk, but the impact cereal is ambiguous. 5. If the price of pasta increases and consumer buys more pasta, we can infer that pasta is a normal good and the income effect is greater than the substitution effect. Pasta is a normal good and the substitution effect is greater than the income effect. Pasta is an inferior good and the income effect is greater than the substitution effect. Pasta is an inferior good and the substitution effect is greater than the income effect. So first, this is the situation. We have the quantity of pasta. This is the maximization. The other one is the quantity of the other good. Doesn't matter which is at that time. Then when there is a change in the price, automatically the budget constraint gets flatter. Then imagine that this is the situation that this person consumed more pasta. So then the consumption of pasta should increase. If we can disaggregate all the movement of the total effect, we can split in substitution effect and income effect. Then remember the substitution effect, you need to take the new slope of the budget constraint. You need to move until it gets the same slope with the first indifference curve, and this you get a bundle. This bundle, when you move from the original bundle, you see here there is a decrease compared, it is less quantity of pasta. So then this is the substitution effect. This is the quantity that you are replacing of pasta for the other good due to the increase of the price. What happened with the income effect? The income effect is the movement for the new bundle that you have just built with the movement of this imaginary income that you need to provide the individual to get the original indifference curve. So this is the income effect. So then remember a given good. A given good is a weird good that when the price goes up, you consume more. And given good is like an inferior good. So then when the price, when the income increase, this case the consumption decreases. So then the given could be a synonym of inferior good. So we need to verify the situation in the last two one. And the income effect is greater than substitution effect. That's correct. This income effect is higher than the negative effect that we have here and the substitution effect. So then this should be our answer. Then the last one. The labor supply curves slopes upward if leisure is a normal good, consumption is a normal good, the income effect on leisure is greater than the substitution effect, the substitution effect on leisure is greater than the income effect. So then, remember the situation explained in the chapter. We have the left graph, the relationship between the consumption and the hours of leisure. We have a constraint, and we have here a difference curve, and naturally will they crosses when they are tangent each other. So then we have the maximization. Then imagine this situation that you have a higher salary. For this reason, it can be represented in a higher consumption. However, we see here how the hours of leisure they have decreased. So then we see here how with a higher salary you provide or supply more hours to the market. So then this is upward, okay? Then we know here that this is one situation. So then this is the other one. You see here which is different. Imagine that you get higher salary, but then you start to work less because you start to value more the leisure time and you get more leisure time due to a higher salary. Then leisure becomes more costly relative to consumption. At the end, this encouraged to change consumption to leisure, which is the substitution effect. And then the income effect, it should be the person tends to have more of both. Those are normal goods. Then, if the substitution effect is higher than the income effect, she will work more. So then the labor supply is upward. Is the other the situation, the substitution effect is higher, or sorry, lower than the income effect, she will work less. Then the substitution effect on leisure is greater than the income effect. So then that was all for this video. I hope you have enjoyed. See you next one. Bye bye.